Welcome back to Mysterious Universe, the place where what you thought you knew is just the beginning. Tonight, we're going to blow your mind. You've seen the charts, right? The neat diagrams of our solar system lined up like marbles on a flat table. Mercury closest to the Sun. Then Venus, Earth, Mars, all perfectly spaced, orbiting in perfect circles on a flat plane. But what if I told you that image is a complete illusion? Our solar system is not flat, it's not quiet, and it's certainly not isolated. What lies above and below the planets you know is a vast layered realm of ice, radiation, magnetic bubbles, and ancient scars from supernova explosions. Picture this. Earth is just a tiny pebble spinning on a galactic current, wrapped in a shield of solar wind, pushing through a void left behind by the death of distant stars. And we are moving fast. At over 500,000 miles per hour, the entire solar system is hurtling through the galaxy like a ship through dark waters. Above us, a massive cloud of icy bodies, the Oort cloud, surrounds everything in a silent sphere, holding the secrets of the early solar system. Below us, shockwaves from long-dead stars form invisible walls, dense regions of gas we can't see, but that may one day shape our destiny. And here's the twist. Some scientists now believe that these layers are not just natural structures, but the remnants of something more. Something artificial? Something ancient? The evidence is thin, but the questions are growing louder. What really lies beyond the orbit of Neptune? Why are comets crashing in from impossible angles? And are we, right now, passing through a dangerous cloud of galactic debris without even knowing it? In this video, we're diving deep into what's truly above and below the solar system. And by the end, you might never look at the night sky the same way again. So buckle up, hit that subscribe button, and let's journey into the cosmic unknown. Let's start by shattering the biggest misconception of all. The solar system is flat. At least, that's how we've been taught. Textbooks, posters, even NASA animations depict the planets moving neatly in circles around the sun, like a clock. But this is a convenient illusion, a simplification, a map drawn for clarity, not for truth. In reality, the solar system is a swirling 3D ballet, tilted, warped, and constantly in motion. Yes, most planets orbit within a relatively thin plane known as the ecliptic. But even that isn't as tidy as you think. Mercury is off by 7 degrees. Pluto, once called a planet, is tilted by nearly 17 degrees. And comets? They often zoom in from above or below, slicing through the plane at bizarre angles like cosmic harpoons. Why does this matter? Because when you imagine the solar system as a two-dimensional disk, you miss everything that surrounds it. You forget the layers above and below, the hidden structures, the frozen debris, the radiation bubbles, the clouds of gas, and most importantly, the sheer motion of it all. You see, the sun isn't stationary. It orbits the center of the Milky Way at over 828,000 kilometers per hour. And as it does, it drags all the planets along with it, forming a helix-shaped trail like a corkscrew moving through space. So when you look up at the stars, you're not just seeing objects sitting in place. You're watching a storm of celestial motion, like standing in the middle of a cosmic river where the current never stops. Understanding this vertical complexity is the key to unlocking the mysteries of our cosmic environment. It explains why certain comets appear from nowhere, why some asteroids behave unpredictably, and why scientists believe there's more mass above and below us than we can currently detect. We're not living on a flat racetrack. We're flying through a layered spiral of dynamic, invisible forces. And the deeper we go, the weirder it gets. Imagine a place so distant, so cold, and so ancient that light from the sun takes a year to reach it. That's the realm of the Oort cloud, a mysterious, invisible shell that surrounds our solar system like a ghostly fortress. We've never seen it directly. No spacecraft has ever traveled that far, but its presence is inferred, like footprints in the snow left by ancient visitors. These visitors are the long-period comets, celestial vagabonds that appear from nowhere, streak across the night sky, and vanish for thousands of years. Their wildly tilted orbits suggest they don't come from the inner solar system, or even the flat Kuiper belt near Neptune. No, these objects emerge from all directions, hinting at a spherical swarm of frozen relics that surrounds us completely. Scientists believe the Oort cloud stretches from about 2,000 to 100,000 astronomical units. That's up to 15 trillion kilometers from the Sun. To put that in perspective, if the Sun were a basketball on the center line of a football field, the Oort cloud would be the farthest bleacher seat. But what's inside this frozen vault? Trillions of icy bodies, comets that never woke up, fragments of the early solar system still intact, leftover building blocks that never formed planets. They're made of water ice, methane, ammonia, and possibly even organic molecules older than Earth itself. Some theories suggest that this cloud didn't form here at all, that it's a cosmic graveyard capturing wayward objects from other stars during the chaotic birth of our galaxy. If true, this makes the Oort cloud the solar system's memory bank, a vault of interstellar history frozen in time. But perhaps the most unsettling idea? If we're surrounded by trillions of icy objects, what happens when one is nudged inward by a passing star, or a gravitational ripple, or something we don't yet understand? That's when comets are born, and sometimes, just sometimes, they come straight for us. If the Oort cloud is the distant shell of our solar system, then the heliosphere is its armor, a shimmering bubble of charged particles that stretches billions of miles in every direction, silently protecting us from the chaos of deep space. But you can't see it, you can't touch it, and yet, without it, life on Earth might not exist. The heliosphere is formed by the solar wind, a relentless stream of charged particles, mostly protons and electrons, ejected by the Sun at hundreds of kilometers per second. As these particles radiate outward, they carve out a cavity in the interstellar medium, forming a kind of force field around everything inside. The planets, the Oort cloud, even the light of the Sun itself. Imagine our solar system sailing through the galaxy like a boat through water. The heliosphere is the bow wave, fending off interstellar debris, magnetic fields, and high-energy cosmic radiation that could fry DNA in a heartbeat. It's not perfect, but it's a barrier between us and the galaxy's more violent tendencies. What's fascinating is that the shape of the heliosphere isn't symmetrical. It's more like a teardrop, compressed in the front where we face interstellar pressure, and stretched in the back like a tail. This shape constantly shifts as we move through different regions of the Milky Way. The boundary where the solar wind finally slows and gives way to interstellar forces is called the heliopause, and it's the edge of the Sun's influence. Voyager 1, humanity's most distant spacecraft, crossed this boundary in 2012. Since then, it has sent back data from a realm that no human object had ever entered before: interstellar space. But here's the twist. The heliosphere might also explain why Earth hasn't been bombarded with cosmic extinction events more often. It shields us, not completely but enough, from the high-energy rays that flood the galaxy. In essence, the Sun isn't just our energy source. It's our cosmic bodyguard. Yet this invisible armor won't last forever. And as we drift into new regions of the galaxy, the forces pressing on it may change, and not always for the better. Our solar system isn't floating in a vacuum. It's sailing through a galactic sea, and that sea is anything but calm. Right now, our Sun, and all the planets, moons, comets, and radiation it carries, is speeding through the Milky Way at over 828,000 kilometers per hour. That's 514,000 miles per hour, and yet we don't feel a thing. But this journey isn't smooth. We're moving through the local interstellar cloud, a patch of slightly denser gas and dust that we've been traveling through for tens of thousands of years. It's not visible to the eye, but it shapes the way cosmic rays interact with the heliosphere. And here's the kicker. Scientists believe we may be leaving it soon. What happens when we exit? No one really knows. The interstellar medium, the space between stars, is filled with radiation currents, magnetic fields, and hidden turbulence. These clouds are remnants of long-dead stars. Supernova explosions millions of years ago ripped through the galaxy, carving out pockets, waves, and shock fronts in space. One of those ancient blasts may have formed what we call the local bubble, a vast, low-density cavity in space that stretches about 300 light-years across. And we're right in the middle of it. Think of it as a cosmic room, one where the walls are made of gas compressed by violence long past. The boundaries of this bubble are denser, while its interior is relatively empty. That's where we are now, in the void carved out by dead stars, moving toward another unknown frontier. But we're not passive passengers. The sun is plowing through this region, its heliosphere warping and flexing under the pressure of what lies ahead. If we enter a denser interstellar cloud, the heliosphere could shrink, exposing Earth to more radiation. Some even speculate that past mass extinctions on Earth could be tied to moments like that, when our solar shield faltered as we crossed invisible boundaries. So next time you look at the stars, remember, you're not just on a planet spinning around the sun. You're riding a star through cosmic weather patterns, drifting between clouds and echoes of ancient stellar cataclysms. And the next cloud is just ahead. Imagine living inside the ruins of an ancient explosion, an event so powerful it reshaped everything in its path, yet left no visible scars. That's exactly where we are. Our solar system resides in a vast emptiness known as the local bubble, a region of space about 300 light-years wide, carved out by supernovae, the deaths of massive stars. These stellar detonations blasted away the surrounding interstellar gas and dust, creating a cosmic cavity, a vacuum with density far lower than average. This bubble is mostly empty, but its edges? They're walls, invisible to the naked eye, but made of compressed gas and dust pushed outward by the violence of those stellar deaths. We can't see them, but we can detect them through ultraviolet and X-ray observations. They form a subtle but distinct boundary between the bubble's interior and the surrounding galactic medium. Why does this matter? Because these boundaries aren't just leftovers from a long-forgotten event. They still influence us today. The shape of the local bubble affects how the heliosphere is molded. It changes how cosmic rays approach the solar system. It even influences the formation of new stars, as the compressed gas along the bubble's edge becomes dense enough to trigger collapse. Even more fascinating, we're not alone in this bubble. Other stars, like Alpha Centauri and Sirius, also lie within the local bubble, which suggests they too have been traveling through this void for millions of years. And now evidence shows we may be approaching the edge. Instruments on board Voyager and other probes suggest a shift in particle density, meaning we could be crossing into a denser region, one that might alter the cosmic environment around Earth in unexpected ways. And then there's the local void, a neighboring region in the galaxy that seems to be even emptier than the bubble we're in. Some astronomers suspect its presence could influence the motion of our galaxy itself, like a gravitational shadow dragging on the Milky Way's rotation. In short, we're not just drifting through space. We're navigating a minefield of ancient explosions, moving from one galactic scar to the next, each one a reminder of how violent, mysterious, and interconnected the universe truly is. We often picture the Milky Way as a flat, majestic disk, its spiral arms elegantly coiling around a glowing core. But that image, as beautiful as it is, tells only half the story. Our galaxy is not flat. It's warped, rippled, and wrapped in layers of invisible structures that extend far above and below its central plane. And our solar system? It's just one of billions of stars orbiting this galactic behemoth, caught in a slow 225 million year-long revolution. Above and below the spiral disk lies the galactic halo, a spherical region populated by ancient stars, globular clusters, and vast amounts of dark matter. These stars don't move in neat circular paths like the ones in the spiral arms. Instead, they follow chaotic, plunging orbits, often diving through the disk at steep angles. Some of these stars are the oldest in the universe, living fossils of cosmic history. And then there's the halo's dark side, literally. Scientists believe that a massive cloud of dark matter pervades the halo, outnumbering the mass of visible stars by a factor of 5. We can't see it, touch it, or directly detect it, but we know it's there, because it holds the galaxy together. But what about the warping? The outer edges of the Milky Way's disk are not flat. They bend and twist, like a vinyl record left in the sun too long. This strange ripple may be caused by past collisions with dwarf galaxies, gravitational disturbances, or interactions with dark matter structures drifting by. It's as if our galaxy was plucked, and it still hasn't stopped vibrating. And we are dancing to that rhythm. As the solar system orbits the galactic center, it also bobs up and down, crossing the galactic plane every 30 million years or so. Some researchers even speculate that these crossings might be tied to mass extinction events on Earth, possibly triggered by increased comet activity from disturbances in the Oort cloud. So no, our cosmic journey isn't a smooth orbit on a flat surface. It's a wobbling, spiraling, multi-dimensional dance, where every layer, every ripple, and every rise or fall holds ancient clues about our place in the universe. In the vast, swirling ballet of galaxies, supernova bubbles, solar winds, and cosmic clouds, one thing becomes strikingly clear. Life on Earth exists in a razor-thin line of balance. We orbit in the Goldilocks zone. Not too hot, not too cold. But that's just the beginning. Our planet is shielded by multiple layers of invisible protection, each shaped by the very structures we've been exploring. Start with the heliosphere, the solar wind's massive bubble, pushing back against galactic radiation. Without it, high-energy particles from supernovae and deep space would penetrate our atmosphere, possibly sterilizing Earth's surface. This invisible force field isn't perfect, but it dampens the worst of the galaxy's anger. Then there's Earth's own magnetic field, deflecting solar storms and shielding our DNA from unraveling. But here's what most don't realize. The stability of that field depends in part on the motion of our solar system through the galaxy. If we pass through a denser region or a cloud of magnetic turbulence, Earth's shielding could weaken, exposing us to dangers we've never experienced. Even the Oort cloud, that distant sphere of icy debris, plays a role. Disturbances caused by passing stars or dark matter clumps can send comets hurling inward, turning Earth into a cosmic bullseye. Some scientists believe that mass extinction events, like the one that ended the dinosaurs, may have been triggered by just such galactic nudges. And what if the local bubble collapses? If the solar system re-enters denser interstellar space, the heliosphere could shrink, letting in radiation, altering climate, and possibly changing the rules of life itself. But perhaps the most profound realization is this. All these cosmic structures, the orbits, the clouds, the bubbles, the fields, form a dynamic, ever-changing web, and we are suspended in it, like a soap bubble on a stormy sea. For now, the balance holds, but it's not guaranteed. That's what makes Earth so miraculous. A fragile oasis, surviving in a galaxy carved by explosions, wrapped in invisible threads, and spinning through a universe that doesn't care if we live or vanish. And somehow, we're still here. As we zoom back from the shimmering shell of the Oort cloud, glide past the invisible heliosphere, and rise beyond the local bubble's scarred walls, one truth becomes undeniable. We don't just live in the solar system. We drift in the layered memory of a galaxy shaped by chaos. Each structure we explored, from the planetary plane to the dark halo of the Milky Way, isn't just a backdrop to existence. It's an active force, protecting, threatening, and constantly sculpting the conditions that allowed life to bloom on a pale blue dot called Earth. For most people, the solar system is a tidy model in a science textbook, neatly arranged, easy to grasp. But today, we've torn through that illusion. We've revealed a cosmic reality where up and down are myths, where the Earth is shielded by bubbles we can't see, drifting through a universe more hostile and more magnificent than we ever imagined. And yet, here we are. Life emerged not because the universe made space for us, but because, by some improbable dance of timing, gravity, and radiation, our fragile world held its line through billions of years of chaos. It should make you feel small, but also lucky, because now you know we're not just circling the sun, we're riding a star through a galactic ocean. So the next time you look up at the night sky, try not to see it as out there. See it as all around you. The solar system isn't a flat plane, it's a sphere of influence in motion, a pocket of balance in an unbalanced universe. And perhaps that's the most beautiful truth of all. If this journey changed the way you see our place in space, share it with someone who still thinks the solar system is flat. Hit that like button to help us reach more cosmic explorers. And if you're not already subscribed, now's the time. Because we've only just begun mapping the mysteries of the universe. Until next time, stay curious. This is Mysterious Universe, signing off, beneath, above, and beyond.